Good day everyone, welcome to Medix Mike YouTube channel. So today we're going to be talking about how to balance redox reaction. And before we go into details on how to balance redox reaction, I would want us to look at the basic or the major definitions of what redox reaction is. Now, redox reaction is a reaction that involves two processes, which involves reduction and oxidation. Now, these are two reactions that occur simultaneously and have opposite effects in a particular reaction. Now, first we are going to be looking at different definitions of redox. So these are the basic or rather major definitions of oxidation and reduction. Remember, as I earlier said, these two reactions tends to go in different directions. They occur the same time in the reaction, but they have opposite effect in the reaction. So what I'm trying to say is that while one is undergoing oxidation or while one is undergoing loss of electron, the other is undergoing gain of electron. So it is like the inverse of it. So we are going to be explaining what we mean by oxidation is defined as the loss of electron. Now, by saying oxidation is defined by the loss of electron, we mean that when sodium atom, so this is sodium atom over here, sodium atom undergoes oxidation reaction, it will form sodium ion. Now, there are two major differences at this point between sodium atom and sodium ion. Now, this atom here has 11 electrons, which is because it is at its neutral stage and its charge is equal to 0 because it has equal proton number and equal electron number. But for this ion, which is sodium ion, it has 10 electrons. Generally, metal ionizes by the loss of electron. So neutral sodium will lose one electron to form sodium ion. So you can see here that it undergoes oxidation by the loss of electron. Now, our number 2 says that it is defined as the increase in oxidation number. Now, the increase in oxidation number is simply saying that at this point the sodium atom has a charge of 0 because its electron is counterbalancing its proton, therefore having the same proton and electron ratio, which makes its charge to be 0. So at this other point there is an unequal distribution of proton and electron. So we have 10 proton there, we have 10 electrons there and 11 proton. So you can see that it is unevenly distributed. So at this point the charge here will be +1. The charge will be +1. So you can see that oxidation reaction involves the loss of electron number 1 and it involves the increase in oxidation number. Now, number 3 says it involves the addition of oxygen. It involves the addiction of oxygen. So this is what I mean by it involves the addiction of oxygen and it involves the removal of hydrogen. So for oxidation reaction here we are focusing on the oxidation reactions. So for the oxidation reaction you can see that hydrogen is being removed. When you remove hydrogen from a compound, it simply means that you are attempting oxidation or you are carrying out an oxidation reaction. Now if you look down here, you can see when oxygen is being added to a compound, when there's addition of oxygen. Now for the case of oxidation here, note that we are taking our product side as the reactant side, so we are inversing it because the reactant reactions here for the both equations here, for the both chemical equations, are denoting reduction. So from that equation, we have been able to denote that oxidation involves the loss of electron, oxidation involves the increase in oxidation number, and oxidation involves the addition of oxygen and the removal of hydrogen. Now, oxidation number 4 also says oxidation involves or is defined as the addition of electronegative elements such as sulfur, nitrogen, bromine, fluorine, etc. So we are going to be going over to reduction now. Reduction is defined as the gain of electron. It is defined as a decrease in oxidation number. At this point, we are going to be using chlorine as a case study here. So we'll be having a neutral chlorine atom. This is a neutral chlorine atom. Undergo reduction. So undergoing reduction to form chlorine ion. So this is chlorine ion. Now we're going to be talking about number 1 first. So it says it is defined as the gain of electron. So it should be established now that reduction generally involves or non-metal ionizes by the gain of electron. So at this point we have chlorine. The atomic number for chlorine is 17, and that is equivalent to its proton number. So since this atom is neutral, we'll be having 17 electron and 17 proton respectively. So at this other point, which is chlorine ion has uneven distribution of proton and electron. Though its proton number will remain the same, but its electron number will not remain the same. So at this point it will have electron of 18, because non-metal ionizes by the gain of electron. So this will be 18. So it is clear that number 1, which is reduction is defined as the gain of electron, has been satisfied in this reduction reaction, and also it is defined as a decrease in oxidation number. Remember, we have been saying that for a neutral atom, the oxidation number here will be 0, while here the oxidation number of this ion will be -1. So here we can see that there have been reduction or decrease in oxidation number from 0 to -1, because 0 is definitely bigger than -1. Now you can simply go back to this video and look at the removal of oxygen and the addition of hydrogen in that previous reaction I showed you, and see how it is done. So number 4 says that it is the removal of electronegative elements such as sulfur. So I told you these two reactions, though they occur simultaneously, but they undergo opposite processes, opposite reactions. So while this one involves the addition of electronegative elements, this one involves the removal of electronegative elements.